Today we are going to use the substitution method when solving systems of equations. We have used the substitution process just in a different way in the past. Typically, you use the substitution method when you have an equation such as y equals 3x plus 5 and you're told x equals 2. Typically, we just plug in the 2 for the x, multiply, and simplify. We're going to do the same thing, but instead of x being one number, or the thing we're substituting today being one number, it can be more than one number. So remember, when we're talking about systems of equations, both equations represent the exact same situation in just a different way. So we have two equations here, y equals 7x plus 25 and y equals negative 5x minus 11. These two equations give us two different values for y. Y is 7x plus 25 and y is negative 5x minus 11. Since both of these are equal to y, we can set these two equations equal to each other. By setting the equations equal to each other, we now have only one variable in our equation to solve for. With these two equations, we are left with x. So we are going to solve by x. I always start by moving my variable. It does not matter which one you move first, but I chose to move my variable first and simplified. Once I simplified that, I simplified my constants, and then I divided by my coefficient or my number in front of my variable, and I found out that x is equal to negative 3. Now that I've solved for one variable, I need to solve for the other. So I'm going to go back to my original equations, keeping in mind the answer I just found. And I need to choose one equation to work with. It does not matter which equation you work with, I just chose the top one. Once you choose one, you're going to plug in the variable you just solved for. So we just solved for x, and we found out that x equals negative 3. So every time I see an x, I'm going to plug in a negative 3. And then I will simplify that, and I found out that y equals 4. So my solution to this system of equations is a coordinate point, and that is negative 3, 4. X was negative 3 when I solved it, and y was equal to positive 4. Sometimes equations don't come in the form of both of them saying y equals, such as this one says x equals 3y plus 5 and 2x minus 4y equals 12. We can still use the substitution method here. Notice how one equation says x equals. One equation has a variable all by itself. So we can take whatever x equals and plug that in for every x we see into the other equation. Once we do that, we can simplify by using the distributive property, and that will give us 6y plus 10 minus 4 equals 12. We can combine our like terms and then solve our equation for y. Now that I know what y is, I can go back and solve for x. Once again, I choose one equation, and I chose the equation that says x equals just because it will be less steps in the end. I plug in my value of 1 for y since we discovered that y equals 1, and then I simplify the equation that I have there, and I find out that x equals 8. So that means my solution to this system of equations is 8, 1, because x equals 8 and y equals 1.